secret machine. It crossed the mountain in just one day. Welcome to the latest issue of Top Secret. America's secret super drill has just been exposed, a technological monster even more terrifying than that. While the world still firmly believed Velo was the final giant, the destructive drilling machine had been silently operating, capable of tearing apart a mountain in just one day. So what is really happening in this top secret project, and why is it leaving the world astonished? The Alaska Viaduct Replacement Project, the giant drill machine America has always focused on strong development in construction and infrastructure. One of the nation's biggest efforts is the project to replace the aging Alaska Viaduct in Seattle, Washington. To achieve this goal, engineers built a giant tunnel boring machine named Bertha with a diameter of up to 17.5 meters. This is the world's largest earth pressure balanced tunnel boring machine when put into operation in July 2013, costing up to $80 million. Bertha is not just a construction tool but also a leap forward in American transportation technology. Assembled in Osaka, Japan, Bertha was designed to handle harsh underground conditions, especially dealing with natural factors like earthquakes. Notably, Bertha was also programmed to play a special melody throughout its operation, helping workers and supervisors easily recognize the machine's operating. However, this project did not start in 2013 as many people think. In fact, the idea for this project emerged in 2001 when a strong earthquake occurred in Washington. On February 12, 2001, a 6.8 magnitude earthquake shook Seattle, injuring hundreds of people and causing one death from a heart attack. However, the biggest damage was to the city's infrastructure as structures could not withstand another seismic event. Since then, infrastructure reconstruction became an urgent task, with replacing the Alaska Viaduct returning as a top priority. This project was not simple. Engineers decided to replace the viaduct with a $3.1 billion tunnel connecting two sections of Highway 99. However, tunneling under the city center was a major challenge. The tunnel route had to run 60 meters underground, avoiding columns, cables, and pipes from over 160 buildings. To accomplish this, engineers needed a special tool, the Bertha tunnel boring machine. After completion in Japan, Bertha was disassembled and transported to Seattle. Because it was too large to cross the sea, the machine was divided into parts and reassembled upon On July 30, 2013, the tunnel drilling work officially began. Although from the outside, the drilling process seemed normal, inside, Bertha faced extremely difficult challenges, as it had to drill through layers of soil, rock, and underground structure. The disaster of the Bertha machine, the incident and the revival. Although the route for the giant tunnel project was thoroughly studied and many soil samples were drilled for testing, engineers still could not be completely certain about the construction area's gel. The soil here was very complex and constantly changing in composition, so each drilling step had to be carefully. The Bertha drill machine, despite being a special device, could not avoid unforeseen incidents during operation. Just 5 months after starting, in December, Bertha encountered a serious incident. While drilling 330 meters, the machine hit a steel pipe and stopped operating. This was an unforeseen error, believed to be caused by a supervising engineer accidentally leaving the steel pipe while measuring groundwater level. This incident worsened when the rubber seals around the main bearing failed, leading to cutting and mud entering the machine's critical parts, causing damage and overheating. All on-site repair efforts failed, and after 2 months, Bertha remained stuck underground, about 36 meters deep, unable to move. Engineers from Hitachi, the machine's manufacturer, decided that the only solution was to dig out and disassemble Bertha. However, the repairs faced many difficulties, and after months of disputes over costs and sample inspections, the repair work was only completed in December 2015, near Christmas. When Bertha resumed drilling, engineers breathed a sigh of relief, but the challenges did not stop. A year later, as Bertha continued drilling, the machine encountered a hard clay layer mixed with sand and gravel at a depth of about 36 to 46 meters under the Alaska Viaduct. This soil layer caused a large sinkhole about 30 meters from the machine, forcing Bertha to stop for 6 weeks while engineers handled the sinkhole. After 3 months, tunnel work resumed without issues until some minor adjustments were made in March 2017. Finally, on April 4, 2017, Bertha completed its work by drilling through the concrete cap at the receiving pit, creating a dense cloud of dust in the presence of the medium. However, the end of this machine was quite tragic. After completing its mission, engineers began disassembling Bertha into smaller parts, each weighing about 9 tons. for road transport and reuse in other projects. Although Bertha became a historical symbol for America and the world, it was not the only drilling machine produced by the U.S. The U.S. never did sell us another giant drilling machine that they tried to keep secret from the public. The mysterious tunnel boring machine and historical discovery. After Bertha completed its mission and became a historical symbol, America did not stop but continued to develop more powerful tunnels. In 2017, they started a new project named the Chesapeake Bay Bridge Tunnel in Virginia right after Bertha finished its work. However, this project encountered many difficulties and delays. Although initially planned for completion in 2022, unforeseen obstacles extended it by another 5 years. To accelerate progress, American engineers deployed the giant Chesapeake Tunnel board, also known as chassis, which began work in February 2023. However, after drilling about 230 meters, workers discovered a large steel piece on a conveyor belt, and unexpected. After inspection, engineers found this could be the remains of a ship that sank over 50 years ago. A steel piece engraved with the words VKFL via Encore, a famous company in Sunderland, England, which produced ship anchors from the 19th to mid-20th century. This made people wonder how the anchor got buried underground and which ship it belonged to. The chassis tunnel boring machine had accidentally dug up this anchor weighing from 1.5 to 2.3 tons. After the discovery, engineers had to halt chassis operations for investigation and excavation. The repair process lasted over 6 months, replacing 389 out of 442 tools on the machine's cutting head. Another 3 months were needed for the machine to resume operation. When work continued, chassis drilled about 15 meters per day and had completed 480 meters out of the total 1,600 meters, achieving 25% of the estimated total length. The project is expected to be completed by the end of 2020. However, although chassis and Bertha are famous drilling machines, they are not unique. There are many other types of drilling machines worldwide, with more sophisticated tech, and to understand them clearly, it's necessary to study how they operate and the specific characteristics. How tunnel boring machines work. Tunnel boring is a mechanical drilling process used to excavate underground tunnels. Although it sounds simple, the process is actually much more complex than we imagine. Tunnel boring machines typically weigh over 6,000 tons and are about 150 meters long, not an easy machine to operate. Due to their enormous size, these machines cannot make sharp turns. Instead, they bored tunnels using a rotating cutting head, called a cutter head, to create a large hole underground. This cutting head operates using engines, which can use hydraulic or electrical systems, depending on the characteristics of each tunnel. The cutting head can be made from various materials, depending on the soil and materials the machine needs to drill through. This drilling machine generates a powerful thrust that helps the cutting head continue rotating and drilling. Behind the cutting head is a working platform called lagging equipment or backup, where other equipment such as transformers, ventilation fans, and other tools are placed. After completing each drilling segment, the machine stops to install concrete rings inside the tunnel to maintain structural stability as the machine continues moving. However, tunnel boring machines are not the only tools used in these massive construction projects. They're just a small part among other giant machines. The giant haul truck VIS 75710, the king of vehicles. VIS 75710, a giant haul truck, is one of the largest vehicles in the world and worth up to $7 million US. This vehicle can be produced in various sizes, with one version weighing up to 90 tons and another weighing only 13 tons. However, the special feature of VIS 75710 is its capacity to haul up to 450 tons and withstand up to 500, an astonishing number, enough for it to set the Guinness World Record for the truck with the largest hauling capacity. Not only that, VIS 75710 also holds a second Guinness World Record for tank capacity, with the ability to hold 645 cubic meters, larger than it. The length of this vehicle reaches 20 meters, width 10 meters, and height over 8 meters. When overloaded, its total weight reaches 850 tons, equivalent to the weight of 2 Airbus A380 passenger aircraft. When transportation to the construction site is needed, this vehicle is too large to move by road, so it must be disassembled and transported on 20 railway platforms, occupying an entire. VIS 75710 is equipped with two 16-cylinder engines, each producing 2,300 horsepower, totaling 4,000. Each of these engines has a displacement of about 76 liters, 100 times the displacement of a regular car engine. With nearly 10,000 newton meters of torque, This vehicle is much more powerful than a vehicle like the Hewis, which has only about 500 Nm of torque. This allows this 75,710 to power two generators, producing 35,000 kilowatts cap, enough to supply electricity to 1,000 apartments. Each apartment requires about 3. This vehicle operates entirely on electricity, with 4 electric motors, each with a power of 1,600. All 8 wheels of this 75,710 are powered by these motors. Each VIS tire weighs nearly 6 tons and costs from $50,000 to $90,000, equivalent to the price of 2 to 4 regular cars. The tires have a diameter of up to 4 meters and are inflated to 7 atmospheres. If a tire explodes, it will create a crater as large as 3 grenades exploding simultaneously. The fuel tank of this 75,710 has a capacity of 2,800 liters, 55 times the capacity of this vehicle can run about 100,000 kilometers per year and be used for 10 to 12 years, with a total distance it can travel exceeding 1 million kilometers.
However, this vehicle also faces many operational issues, especially in dusty quarries.
VIS 75,710 needs to have its air filters replaced frequently to maintain. First introduced in 2012, this 75,710 set a new milestone in the giant truck industry. With a maximum speed of only 64 km per hour, this vehicle is not the fastest means of transport, but its power and work capability are unmatched.
The giant front shovel wall 2350.
One of the next giant machines is the front shovel wall 2350, manufactured in Longview, Texas by Leno Company.
This is the world's largest shovel designed to move minerals such as gold, coal, copper ore, and many other materials into giant trucks.
The weight of this machine is even heavier than a Boeing 737 airplane, about 2 stories high, and can lift a weight equivalent to 40 cars. This shovel is equipped with a large bucket that can hold up to 50 cubic meters, capable of lifting 80 tons of material. To visualize, 53 cubic meters is equivalent to about 5 standard dump trucks you often see on the road. The front shovel is a relatively new type of machine compared to other excavators, although Leno Company has a long history in manufacturing shovels. Roller 2350 is the first model produced here. They also have a testing area to check and control the performance of the machines.
Designed as trucks became increasingly larger, engineers spent 2 years developing a shovel that could lift 50% more payload than previous models.
To achieve this, they also collaborated with Firestone to create the world's largest tires. These tires are up to 4 meters tall, wider than 1.5 meters, and became the largest rubber parts ever seen. The engine of Roller 2350 is a diesel 16 silane type, turbocharged and with an after-cooling system. With a power output of about 2,300 each working hour, it consumes about 190 liters of fuel. This engine powers a generator, which in turn supplies electricity to 4 electric motors that move the shovel. The entire machine is controlled by a giant 16-inch hydraulic oscillator, capable of lifting a bucket and scooping enough material to fill an Olympic swimming pool in just a few swoops.
Caterpillar 609 OFS, the giant excavator.
Caterpillar 6090 FS is one of the most impressive machines in the world, weighing up to 1,100 tons, equivalent to more than 1,000 average cars stacked together. The massive size and weight of this machine reflect the sophistication in design and manufacturing engineering. Equipped with a powerful 793 horsepower engine, Caterpillar 6090 can excavate up to 37 meters deep and move up to 90,000 cubic meters of material per day, equivalent to excavating a football field to a depth of over 30 meters. This capability makes it an ideal tool for large projects such as bridge construction, high-rise buildings, or mining. Equipped with advanced technology like GPS, 3D modeling, and automatic control systems, Caterpillar 6090 can excavate accurately and efficiently, helping to shorten construction time and reduce fuel consumption and costs. Sensors and cameras mounted on the machine allow the operator to monitor the entire excavation process and make timely adjustments during work. The machine also has an easy-to-use control system, helping to minimize operator fatigue and enhance work efficiency. The cabin is designed for the widest and most comfortable visibility, helping the driver avoid stress throughout the work process. Additionally, the machine has a centralized lubrication system, making maintenance easier when oil needs to be changed for moving parts and providing quick access points for maintenance. Caterpillar 6090 FS not only has excavation capabilities but can also participate in mining, construction, and demolition work. With its massive size and power, it is an ideal tool for large-scale projects. The machine is also equipped with numerous safety features, including an emergency shutdown system, fire suppression system, and roll. The advanced technology of Caterpillar 6090R enables high-precision excavation, saving fuel and overall costs throughout its service life. Leaper LR1300 crane with unprecedented lifting capability. The Leaper LR1300 crane is one of the most powerful cranes in the world, capable of lifting up to 3,000 tons. Manufactured in Germany, this crane demonstrated its strength by lifting a test load of up to 3,300 tons at Leaper's factory. With its special design, the LR1300 can lift large modules in nuclear power plants and refinery towers that can weigh up to 1,500 tons and be over 100 meters tall. Each crawler of this crane is over 3.5 meters high and weighs more than 200 tons, with a hook alone weighing a ton. With a maximum boom system length of up to 246 meters, the LR1300 uses a 20-meter main boom and a 26-meter luffing jib to achieve optimal lifting capacity. This crane can operate without the need for a direct counterweight system, such as an internal production rotation. If necessary, we can use an adjustable suspended counterweight system, similar to the LR1350 with a counterweight radius from 20 to 30 meters. The LR1300 can operate even with a heavy counterweight pulling system, making it easy to move large components. Notably, each part of this crane is transported and assembled very carefully, including disassembling the 82-ton crawlers and other heavy parts. With its massive dimensions and tremendous power, the LR1300 is truly an impressive crane in the mechanical world. Big Muskie, the giant mechanical monster in history. Big Muskie is the largest and most impressive dragline excavator ever built, known as a mechanical monster. Standing nearly as tall as a 22-story building and weighing up to 10,000 tons, Big Muskie was created by the Ohio Coal Company to mine coal from vast mines here. This coal mine spans over 44,500 hectares, an area large enough to require a machine of enormous size to dig earth and extract. After 3 years of construction, Big Muskie was completed in 1969, costing about 200,000 labor hours to assemble and amounting to $25 million at the time, equivalent to about $17 million today. Big Muskie's bucket has a capacity of up to 220 cubic meters, equivalent to 2 full-sized bus-rate hump trucks. A report in 1976 stated that this giant machine could excavate 8,000 cubic meters of earth per hour of operation. Big Muskie's electrical power consumption is so large that it equals the electricity demand of an entire. The machine uses 13,800 volts through a long trailing cable to power 18 electric motors with a total capacity of up to 1,000 horsepower. Operating this machine is quite costly, amounting to tens of thousands of dollars per hour just for electricity.
With its enormous size, Big Muskie can move itself using giant hydraulic legs.
However, its movement speed is very slow, only about 0.16 kilometers per hour, almost imperceptible. The machine operated for 22 years, digging over 600 million cubic meters of earth and extracting.
However, due to rising electricity costs and strong opposition to open-pit coal mining, Big Muskie had to cease operations in 1991. After decommissioning, the machine was dismantled and sold as scrap.
Only its giant bucket remains and is currently on display at the Miners Memorial Park in Bristol, Ohio, where the former Big Muskie operation site has been converted into a wildlife park, home to many species from different continents. Komatsu D575A3 Super Dozer, the powerful beast in construction. Modern technology and superior power are the factors that make the Komatsu D575A3 Super Dozer special. This is the world's largest and most efficient bulldozer, twice as powerful as conventional bulldozers. With a unique design from Komatsu, every component such as the hydraulic system, engine, and frame is manufactured in-house, ensuring the highest performance and reliability. The machine is equipped with a powerful engine with a capacity of up to 858 kilowatts, equivalent to 1,150. The turbocharged and after-cooled engine allows it to operate smoothly and save fuel. The D575A3's blade has a capacity of up to 90 cubic meters, hoping to reduce operating costs. The control system is intelligently designed, allowing the operator to easily control the machine with a conveniently designed steering wheel. It provides the most comfortable feeling for the operator. Another special feature of the Komatsu D575A3 is its intelligent electronics, which optimizes the performance of machine components such as the transmission, brakes, and clutch. The machine is also equipped with a seat that can adjust tilt and steering controls, helping the operator achieve the most comfortable working posture. The machine's mobility is very flexible thanks to the undercarriage and shock absorbers that reduce shaking during work. The suspension system and shock-absorbing components allow the machine to move smoothly over various terrains,
minimizing damage and making work more efficient.
The Komatsu D575A3 is not only a giant bulldozer but also a testament to significant advancements in mechanical and electronic, optimizing all tasks from earth moving to large-scale construction projects.
Bagger 288, an excavating machine larger than a building.
Yet the Komatsu D575A3 is a beast of construction, and Bagger 288 is a symbol of enormity and power in mining. Manufactured by the German company group in 1978, Bagger 288 was once the world's largest mobile vehicle, surpassing even the Knocker transporter used for spacecraft. Weighing up to 45,000 tons and standing 95 meters tall, Bagger 288 is taller than the Statue of Liberty and heavier than the Eiffel Tower. Bagger 288 was designed to mine at a Hobart mine in Germany, capable of excavating up to 265,000 tons of lignite coal per day. With a giant rotating digging wheel, Bagger 288 can move 240,000 cubic meters of earth and rock. Each bucket of the machine can hold up to 23 cubic meters of earth and rock, equivalent to the load of a large truck.
With the ability to quickly excavate a large area, Bagger 288 saves a lot of time and labor.
A special feature of Bagger 288 is its slow but steady movement capability. The machine can move at a speed of only 0.64 km per hour, and to complete a 22 km journey, Bagger 288 needs up to 3 weeks.
However, the machine does not always move easily. When crossing rivers, it requires thorough preparation, even costing up to $10 million for each river crossing.
The machine uses 4 large engines with a total power of 3,360 kilowatts, equivalent to the power of about 30 Although it ceased operations in 1991 and was dismantled in 1999, Big G 288 remains a symbol of mining technology.
S giant bucket is still displayed at the miner. Though no longer operational, Big G 288 still impresses as a machine capable of transforming landscapes and efficiently extracting resources.
Both the Komatsu D575A3 and Big G 288 demonstrate peak creativity and technology in the construction and mining industry. These machines are not only massive but also symbolize strength, efficiency, and technological progress. Holders clearly recognize the importance of applying technology to heavy and challenging tasks. Giant tunneling projects not only represent a significant leap in American construction technology, but also prove perseverance and creativity in overcoming challenges. If you found this video interesting, don't forget to subscribe to the secret channel Beyond the Veil. Thank you for watching the video, and see you next time.